A four-stroke engine is a very common variation of an internal combustion engine. Most modern internal combustion-powered vehicles are four strokes, powered by either gasoline or diesel fuel. During engine operation, pistons go through four events to achieve each power cycle. The definition of an event is an up or down piston motion. Upon completion of the four events, the cycle is complete and ready to begin again. Four-stroke engines deliver a good balance of power, reliability and efficiency. When it comes to emissions, four strokes separate each event mechanically, which reduces on-burn fuel emissions. It also separates oil from fuel, which significantly reduces carbon monoxide emissions. This combination of desirable traits has earned the four-stroke the top spot in passenger vehicles today. In order to effectively power equipment, four-stroke engines complete and repeat the following steps. Intake stroke. Piston moves down the cylinder bore from top dead center, TDC, to bottom dead center, BDC. Intake valve is open, the exhaust valve is closed. Downward piston motion creates a vacuum, negative air pressure, that draws that air, fuel mixture into the engine via the open intake valve. Compression stroke. Piston moves up the cylinder bore from bottom dead center to top dead center. Both the intake and exhaust valves are closed. Upward piston motion compresses air, fuel mixture in the combustion chamber, power stroke. At the end of the compression, previous, stroke, the spark plug fires and ignites the compressed air, fuel mixture. This ignition, explosion forces the piston back down the cylinder bore and rotates the crankshaft, propelling the vehicle forward. Piston moves down the cylinder bore from top dead center to bottom dead center. Both the intake and exhaust valve are closed. Exhaust stroke. Piston moves up the cylinder bore from bottom dead center to top dead center. The momentum caused by the power stroke is what continues the crankshaft movement and the other three strokes consecutively. Intake valve is closed, the exhaust valve is open. This final stroke forces the spent gases, exhaust out of the cylinder. The cycle is now complete and the piston is ready to begin the intake stroke. The intake valve, on the top left of each image, is open and as the piston travels downward, this suction pulls the air, fuel mixture into the cylinder. Both valves are now closed and the piston compresses the air fuel into a much smaller volume, preparing the mixture for ignition. With both valves closed, the spark plug, located in the picture between the intake and exhaust valve will fire, igniting the air, fuel mixture. The resulting explosion forces the piston downward and rotates the crankshaft, which in turn propels the vehicle. The exhaust valve, on the top right of each image, is now open, allowing the piston to push the spent exhaust gases out of the engine as it rises. The four strokes, one engine cycle, are now complete, and the process repeats. Air is compressible. When the air, fuel is compressed before ignition, combustion efficiencies are improved. Compression ratio is the relationship of total cylinder volume to compressed volume. For example, a compression ratio of 10:1, verbally spoken as 10:1, would indicate that the chamber squeezes 10 parts of air, fuel volume into 1 part of that volume at the end of the compression stroke. Higher compression ratio can offer more power in some applications. The downsides to higher compression ratio can be decreased durability and the need to run higher octane, expensive, gasoline. Air and fuel enter the cylinder via the intake valve, and spent exhaust gases exit through the exhaust valve. Use of valves is one of the major differentiating characteristics of a four-stroke engine compared to two strokes. The total number of valves per cylinder will vary based on engine design, 2, 3, 4, 5, but each valve can only be either an intake or an exhaust. Valves open and close at predetermined times in relation to the piston, allowing for reliable and efficient power generation. Engine and valve train configurations vary, but the goal remains consistent. A camshaft is precisely timed to the crankshaft, and they work together to manage the mechanical operation of the engine. In push rod valve actuation, the camshaft gear is driven off the crankshaft. In direct valve actuation, the camshaft is driven by the crankshaft via a timing chain or belt, also known as an overhead cam engine. While the engine crankshaft controls the up and down motion of the piston inside the cylinder, the camshaft is responsible for opening and closing the valves.